We're set, yeah.
Hello, good evening. We are Cellular Metrics. I'm Zach.
I'm Alec.
I'm Dave.
I'm No Frank.
Our sponsor, Clark, as well as the ECTET crew and our coach, Rick. And let's get started. We'll go right to Alec for an explanation on our domain.
Hi. So the different mobile carriers all make claims such as, oh, we are the most reliable network, or we have more coverage than our competitors, or we're America's fastest network. But these claims aren't necessarily backed up in any data. So that's kind of our goal here, is to gather that data and show it in a way that the average consumer can understand, so that way they can make an educated decision. The way we go about this is through crowdsourcing the data. So instead of sourcing our data from the companies making these claims, we get it from the average person who is using these services, so that way we can see what the actual real person is experiencing in different parts of the country. And that allows users to make decisions based on what other people are experiencing, so that way they can make an educated choice to which carrier they want to pick. Our sponsor in the project, I mentioned about a week and a half ago on local news, so we're going to show a clip from that which will explain things also.
Yeah, a lot of you have been talking about your cell phone coverage.
Rick was professor at RIT has an app for that. New this morning, Casey Jones looked into this. She's live in Pittsburgh, where a lot of you have been dealing with dropped calls. So Casey, how does this app work?
Well, it's very simple. All you have to do is download the RIT Cellular Metrics app. It's free. Now, this app will tell you your download speeds and coverage in your location. Now, here in Pittsburgh, where a lot of you have been dealing with that spotty cell phone service, it could be a useful tool. Now, of course, cell phones are an important resource we use in our everyday life. We're not just making calls on them. Now we're using them to surf the internet, for shopping, reading the news, watching TV, and much more. Now, of course, if you don't have signal strength, you can't do any of that. Carriers like Verizon, T-Mobile, AT&T, Sprint, sometimes all claims have more coverage and faster networks, and now consumers can actually find out. The Cellular Metrics app allows you to measure actual download speeds to your carrier and compare those results to other carriers. Researchers use crowdsourcing to collect data for the app to make the coverage map. Professors at RIT who developed the Cellular Metrics app say it can be a useful tool for carriers to understand how they can improve the service for consumers.
Coverage is the basic foundation of being able to do wireless communications. If you don't have radio frequency coverage, there's a link between the base station and the mobile device, nothing is going to happen.
And if they're having trouble with their carrier and having poor performance at their home or at their workplace, they can go through and run a specific test. They can run a download, upload test. You can collect that data and can share that data with their carrier.
The app is designed with privacy in mind. It does not collect personal information. For the app to work best, researchers need more people to download it so that they will have more data about signal strength and connection speed. Now again, it is a free app. You can download the RIT Cellular Metrics app from the Google Play Store. It is available on Android phones. Reporting live from Pittsburgh, Casey Jones, News 10 NBC Today.
Okay, so hopefully you guys have a better idea of the domain that we're dealing with here. So now let's talk about what we inherited from the previous team. If I can skip the slide. All right. So this was a continuation project for software engineers worked on this last term as well. So we inherited three major components. One, the Android app you just saw there on the news. Two, a bandwidth test server, a very basic, maybe 200-line Python server that acts as something you can push data up and pull data down in a way to test your bandwidth, upload, and download speeds. And finally, a data collection server. This is kind of the heart of the whole system. It stores all the data and provides the endpoints for the app to upload data, as well as pull down the aggregated data so that it can be displayed for the user. So obviously we've got a lot coming in. You might be wondering, what are we doing this term? So at the start, the first couple weeks, we were thinking about testing. They didn't give us any testing from last term. That was something we were going to focus on, as well as scaling. Right now, the server runs in our sponsor's office right now on one machine. And obviously, as we increase our users, that's going to have to change. And obviously with this new coverage on the news, that's increasing already, and we're seeing that. So about week 3 or 4, our sponsor came to us and explained to us where he wanted to go for the term. And it was a big change. It's more towards first responders in crisis. So if you remember at the start of the term, all the hurricanes that were destroying down in the south. So you're probably wondering, how does the crowdsourcing technology we have help them? And the answer kind of lies in they need to know where people don't have coverage, right? If they don't have coverage, they can't call emergency for help, right? So they want to know, okay, where's there no coverage, and go there to help first. So that's the major feature we delivered this term, was to tell, first responder kind of version of the app where they can see live where people don't have coverage. And it expands further than just this, so much that our sponsor actually went out to Colorado this term about week 6 or 7 to NIST Labs. They have a committee that is devoted to first responders and public safety communication. And this conference they were holding was specifically dealing with the topic of the advancement of mobile networks, deployable mobile networks specifically. So what that is disaster happens, right? Network's down or congested. Emergency responders can't talk. They need to talk. So they need to set up a network for them to talk. And here's an example of one of the products that was displayed is these drones would go fly up in a disaster area with antennas on the top acting as mobile towers, and then that would enable first responders to communicate, which is obviously very important. So hopefully you can kind of see where we might transition into this kind of a realm and this kind of a domain now. There's ideas from our sponsor that maybe next term we'll create some sort of simulation to say, okay, we have this downed area, and maybe if we have a tower here, here, and here, bandwidth will be able to be increased to a level where they need to communicate. And on the right there, it's kind of a simulated picture that they saw at the conference as well. So now that you have an idea of the domain, what we inherited in the problem, what we're addressing, Zach's going to talk about our process.
So our process. When we started, our first priority was finding something that would allow us to hit the ground running. We inherited an application that was already pretty detailed, so we immediately started looking towards more of an agile methodology. We ended up going with an iterative process for a lot of reasons. So for the first major reason was we inherited a pretty thorough and fleshed out backlog from the prior team. A lot of their stories were already present in there. A lot of what they felt needed to be done on the product was in there. And we felt that we could really leverage the work that they had given us to get a little bit ahead and start going at a decent pace. Aside from that, we have a very passionate sponsor, and we were looking for a methodology that gave us the option of always getting feedback, kind of matching what we've done to the vision of the product. And we felt by going with something that would allow us this constant contact, we would be able to bring our application more in line with what they specifically were looking for. So on the technologies that we use, we started with Trello and Google Drive to be the primary repositories for our requirements, our backlogs, and a lot of our other process-specific documents. The Trello we were using, again, was an inherited one, so a lot of the structure of that was a little bit different than we had liked. It was a little bit more chaotic. The Google Drive, we had kind of linked up our Trello to the Drive with requirements. Our primary communication channel was Slack, which, I mean, it's the best. So as the term went on, we noticed that we were having a lot of minor process problems during our first iterations retrospective. We kind of nailed down a lot of the issues we were having were stemming from the fact that we didn't really mesh well with the Trello and Google Drive method of kind of having our backlog on Trello and linking. It was a complicated process, and we really hadn't initially anticipated as much of an issue as it became. So in the interest of switching up early, we switched to Microsoft TFS, and the goal for that was really to take everything that we had spread around and kind of move that all into one centralized repository and area. So from there, we can have all of our backlog stories. We can have definite assignments to the people doing the work, so there's not really confusion, which was an issue we were running into Trello. We can just, overall, our process really improved with that move. On the other kind of looking forward aspect of our process, we anticipate our project to continue on past us. It's already relatively big. So one of the things we wanted to keep in mind was having a methodology and using technologies that would allow us to give a smoother handoff to the next team or the next group of people who will be supporting and developing on the product. So that's another reason why we felt that the move would be good. That's something that we move our process towards, is looking for ways that we can really make a more seamless transition when the time comes for that. So aside from that, we have our product metric. So our process metric is hours per week. As you can see, we did ramp up relatively quickly from our initial starting point. We did have a drop around week 6, and that corresponds to when our sponsor was in the NIST convention. That was the end of our first iteration, and that was really when we uncovered a lot of our initial process issues with the Trello and Google Drive system. It gave us a good chance to pivot, and then from there we had a lot more consistency in our iteration, working hours, and we felt that we really increased the consistency of our iterations. And now we'll go to Noah with our product metrics.
All right. So in addition to this process metric, we also set up and automated the collection of these product metrics. So these product metrics give us solid information on what our sponsor's server is doing, how it's performing, what kind of data we're collecting, how much data we're collecting. It's very important for our sponsor to know how much data we're collecting and if the server is working or not. So that's why we set up this automated process. The main purpose of these metrics is to determine our needs for scaling in the future, in the next semester. And so for example, if we see we have very high bandwidth usage, we can investigate hosting options that allow for very high bandwidth usage, because we're essentially hosting a speed test server. So getting into the technology aspect, the Android application is the client-facing interface with the bandwidth server that we mentioned earlier. The Android application will talk to the bandwidth server to measure your download and upload speed on your cellular connection. The Android application always also, by default, measures the towers you're connected to and the strength to those towers every 15 minutes. So both of these results will be uploaded to the Flask server, which stores them in the Postgres database. The Postgres database can be queried, and this data can be aggregated in different ways. The last team implemented a Google Map API inside the Android application, which shows the coverage of crowdsourced live data from our Postgres database. So if you were to download the app, you could go to the map view and see coverage for AT&T or Verizon and the speed differentials in different areas. Tableau is used by the last team to view data in the Postgres database, but our sponsor hasn't asked us for anything really with that yet this year. We're keeping all of these technologies because the last team spent an entire year developing this project, and our sponsor has not introduced any new requirements that would require us to introduce another technology, so we'll continue to use these technologies. And now for Alec.
So let's talk a little bit about the progress we made this semester. Some of the things we started on originally were fixes and changes that weren't necessarily new features. So one of the things was adding a cooldown to the button that allows you to run upload speed and download speed tests. So prior to this change, users could press the button multiple times and start off multiple connections with the server for downloading or uploading. Another change that we made was actually enforcing limits on the max upload size and download size. Otherwise, users could say, like, oh, I want to do a speed test that uses a minimum of like 10 terabytes, for example, which is a lot of load on our server and could eventually make us have to pay more depending on the hosting service we're using. We also created some mockups for the live view that that our sponsor showed when we went to Colorado. Those kind of focuses you can see on the Houston area as a disaster had just occurred there. We also, on our map view, we dealt with increasing the resolution on that, so that way users could see see the data more clearly and more accurately, as well as implementing a way to allow the user to change which resolution that they're viewing it at. We also dealt with various bugs, such as people having issues with the data stored on their phone uploading to the server, data missing from the map view display, and those are things that we had to address as they're kind of showstoppers. Those affected us in that we couldn't move forward to some of the features we wanted to do. Eventually, we pushed forward and started working on a live view feature, as was mentioned before. This allows the first responders to see things kind of as they're happening, so that way they can address the issue.
So now we're going to step into the actual final live view feature. As you can see from the mock-ups that we showed before, it's not the same kind of visual. We figured, let's use the Google Heat Map API instead of writing our own overlay software. It's way easier, and I think it looks way better. So here is some fake data. Obviously, this is just kind of like a proof of concept. This wouldn't go out to the actual users of the app. This is the first responder kind of version of the app. So they would be able to filter on certain discrete times, so like a day ago, last hour, or last 5 minutes, and see how the cell coverage has changed over that time. So the map right here, this fake data, is centered at Binghamton, New York. So maybe there's a natural disaster there, and over time, the last 5 minutes, we've lost cell coverage in that large area. So then the first responders would know, okay, we need to go to that area to help. And that's kind of the whole idea of the feature that we've been talking about this entire presentation, and that's the final result that we saw this term. Just to reiterate what Alec was saying there, a lot of our time was spent on fixing a lot of showstoppers that we were finding from the last team. There was a lot of bugs that we, took us, weeks just to figure out what was going on. So that's, I just wanted to reiterate that there's a lot of time spent on, fixing mistakes from the other team and basically hardening a new version. That's what they were just demoing in that video at the start, that version 3.8, which you can download now. It's a hardened version. So now Noah's going to talk about the future real quick.
Yeah, so next semester, our #1 priority is ramping up unit testing because it's very important. We've advocated the benefits of unit testing to our sponsor multiple times. Our second big goal is to scale the application. So when we get large user spikes, like the one after the news article and the news coverage, like this one, we can be able to handle that and properly collect data. We currently have 281 active installs, and this is the graph of our active installs. So we want to be able to process all this new data we're getting. Our data processing time went up significantly, so we want to be able to cut that down. We want to continue to find bugs and make it the most polished version of the app as possible, so we can achieve the maximum number of installs we can. And finally, we're going to expand upon the live view feature that Dave just covered. And part of the journey is part of the journey of a crowdsourced app is we need people. So go to join.edu.tech to download our application on the Google Play Store. It's Android only. We would love for all of you to contribute to our project.
Yeah, join the online sensation. You're really contributing to science, and we definitely appreciate every install. Any questions? Yeah.
Have you considered networking limitations by the device? Like some of your phones may go through as much better networking, upload and download than the
Right.
and that might affect the data.
We don't have anything in place to consider that, but that is a good consideration.
Well, there's actually kind of a built-in feature of our app that kind of makes that not an issue, is that when you're doing a test, there's kind of a warm-up period that sees how much bandwidth there possibly could be, so you can actually do the test. Like, how much data can you actually fit through the pipe before you do the test, before you actually get your bandwidth. So we're actually there's like a warm-up section where we don't have the sequence diagram up there, but it will actually figure out how much data you can actually send right away, so that when you actually do the test, you are guaranteed that you're not going to be trying to send or pull down too much data, so you would affect the results. that makes sense.
Yeah?
Any plans for an iOS version?
Not currently, no. We're focusing our efforts on the Android development, and we feel that Android's pretty great. So maybe in the future the scope will expand to include iOS, but no, we don't have any plans at the moment. Yes?
So for your unit test for the first responders, it would seem that the value comes from this app being run continuously. But for the average user, what's the incentive for them to run it all the time as opposed to testing the speed when they first get it?
So I guess their main incentive is if they have all that data on the phone and maybe their coverage has been bad lately, they can see that, oh, T-Mobile is way better than my current Verizon, my location, and they're cheaper for my plan that I like. So maybe I'm going to go switch to that plan. That's the main incentive for like the everyday user.
And at the same time, this is a crowdsourced project, so really just having this app on your phone, you're contributing to a lot of the goals of the project in general. One of the kind of domains we're also looking into is net neutrality, because just the project in general has a lot to do with network trafficking and stuff like that. So really all the data that we do collect will be used to benefit the consumer in some way. So, yes?
So I think kind of going off that question, if besides for running an explicit speed test for upload and download, is the app in the background collecting, like you were talking about, signal strength data all the time?
Yes.
Yeah, passively it runs like 2 tests a day.
Okay.
2 bandwidth tests, yeah.
Yeah, 2 bandwidth tests based on configured value that the user wants. Yeah.
Is the data available for other researchers to look at?
I mean, technically it's a public-facing API. You could go to the link. You could go to, I mean, we don't have the API notes out publicly, but it's technically public. You go to a link and actually pull the data down, but that's currently not like in scope of what we're doing right now.
Yeah.
As you expand in more areas, how do you plan to expand your data testing service?
I mean, that's kind of what next term's about, is researching how we want to do that. We haven't really stepped into that kind of decision making yet, but that's kind of where that's like start of next term is, all right, what cloud services are we going to use to be efficient for like max users? Yeah.
Do you see any potential roadblocks with your testing of applications? In particular, are you going to focus on solely unit testing, or are you also going to use performance testing?
I guess we don't see any roadblocks. I mean, for testing, the Android app, that's pretty simple, as well as the Flask app. There's a lot of frameworks that are around them to test them effectively. We have string test, I'd say, or kind of what's the word? String test, essentially, where we'll walk through the app and test the main features to see that they work. If that's what we're kind of getting at, that's something else we'll do. But in terms of performance, that's kind of all the performance kind of ends on the server end and aggregating the data, which is something we are worried about. As Noah had in that previous slide, the time to run the aggregation scripts has increased by like 40% or something, just with this like 250 plus users. So that's something we're worried about, and we have we have some steps outlined in terms of how to increase the performance.
Yeah, and at the moment our main focus is stepping up our unit testing. We have very light unit test coverage now, and in order to kind of move forward with the application, we're just trying to get that test coverage up. So
Let's thank the team.
All right. Hello, everyone. Welcome to our interim presentation. We are the very originally named team Bike Share. As you can guess, our project was the student government bike share. And as you can also guess, our sponsor was student government. Our coach was Bobby St. Jacques. Here's our team. I'm Kyle Skonezny.
I'm Gareth Johnson.
I'm Tristan Witcher. I'm Grant Cardone.
So to get started, let's give you a little bit of background on what the current bike share system is. So bike share was started back in 2014 by student government with 20 bikes. Right now, if you want to check out a bike with bike share, you have to go to Gosnell Hall, go to the front desk, get a key, and then you have free reign of the bike. You can unlock and lock it wherever you like, but you have to return it before 24 hours is up. And then came October. Spin came to campus. It's a third-party company. They have 100 bikes on campus, and it's a trial with student government for 6 months, which I believe has been extended to the end of the academic year. This is what their application looks like. So it's called a decentralized bike share system, which means you can check in and check out a bike anywhere you like. As you can see, these bikes are kind of strewn everywhere across campus, and you probably have seen them in interesting places on campus as well. So let's get started on our requirements. So initially, after going through the project spec, we found our basic requirements here. So we needed a replacement for the current bike share that was mobile friendly and was available 24/7. They also needed a rewrite of the admin system, so for tasks like bike management, user management, and maintenance. And they were also looking for a new way to lock and unlock bikes that would make the bike share more available and not have people having to go to get keys. After our first meeting, these requirements changed a little bit. We didn't quite think that the lock and unlock process was going to be such a big part of the project, but it turned out to be right on par with the rest of our requirements. And again, our other requirements didn't really change. We had the mobile rider app and a rewrite of the admin system. So this was tough because needing that locking system, that brought into the scope the hardware limitations of having to find a third-party lock that we would be able to easily integrate into our system. And along with that, they kind of gave us a high-level overview of the requirements they were looking for, but they didn't really get down into the details about what specific requirements they wanted from the bike share system. So our solution to this was to seek out possible providers for this lock, but if we weren't able to find anything, we decided that we'd make hooks in the system that were easy enough to implement if student government in the future were able to find a lock that would work within the system. In terms of requirements, we decided to follow the lead of Spin since we would have a good period of time where students were using Spin and getting used to the user interface. So if we were to make the transition from Spin to our bike share as easy as possible, there would be less user confusion in that transition. And we also decided to fix its shortcomings. So Spin, as I mentioned before, the bikes kind of just go everywhere. So we decided that we were going to figure out a good way to keep bikes in locations where students can check them out easily and things like that. So we also wanted to lean on our personal experiences of using bike shares since we have used bike shares in other cities before. And any issues that we ran into, we'd fill in the gaps with questions for the sponsors.
So now that we've covered the requirements for the project, I'm going to talk about everyone's favorite part, which is process. So we began deciding on our process by talking to our sponsors and seeing if they had any requirements for us as far as documentation they wanted, levels of visibility, things like that. Turns out they weren't very interested in formal documentation or any fancy ceremonies to go along with it. All they really cared about was high visibility on the work that we were doing, and they wanted to have functional releases whenever we did stuff. As with most processes, we started out with something and then slightly tweaked it. So we ended up choosing Scrumban, minus the daily stand-ups. We didn't do daily stand-ups. Scrumban provides the benefits of Scrum for agile development. However, it ignores many of the formal ceremonies for documentation as such, as our sponsors weren't very interested in that, and that let us just kind of jump right in and get coding early. It also uses a Kanban workflow instead of a Scrum workflow. So what this allows is more continuous development. There's less strict iterations. There's still iterations, but instead of having like, I want to do X amount of weeks for a sprint and do this amount of tasks, we can pull from our to-do and kind of continuously integrate once we get work done, which allows for a continuous workflow. As such, here's our Trello, which is our main backlog. For visibility, this is available to our sponsors completely, so they can always check in on what we're doing. Future is our backlog of stuff that is not planned for this semester. So these are requirements that we know we need to implement, but we're not interested in working on now. They're going to be next semester. To do is the backlog for the current term, so things that we want to do to finish out this semester that can be pulled from at any time someone wants to work on it. Doing is the stuff that we are currently working on, and then done is all the stuff that is done and tested by someone else on the team.
So now after process, let's talk a little bit about the technology that we use to achieve our goals. So starting off with the front end, we used a pretty simple React Native stack, and Redux joins really well with React in order to implement state management. Alongside our React Native code, we used a service called Expo, which handled the building and the deployment for us, and in return gave us native APIs that we could use with React Native. Things like our map view and QR scanning were very easy to implement through the service. And then from Expo, you would be able to deploy to their servers, which users would be able to use as native applications on both Android and iOS. So the pros and cons of using Expo. The pros are, it was a great continuous delivery system. You would publish your code to their service, and the user would use their client app to scan a QR code, and your app would be immediately delivered to them. And it was very easy for continuous delivery, as updates are automatically pushed to the app once it's opened. It made for really easy builds, just one-click builds or one-command builds, and it made for really easy development as well. The cons is that sometimes dev was really buggy. Instead of pushing up to their server for development, what you would do is you would run kind of an instance of their server on your computer, and you would use the app, their client app, in order to view your live code on the smartphone. It was a great system, but sometimes it's a little buggy depending on your network and what your connection is like to your laptop. And their APIs are a little bit limited, since they do give you these nice native APIs. The problem is that since they're not going to serve any native code for you, you don't get to write any or use any dependencies that have custom native code or write any of your own native code, which means we'll eventually have to shed Expo, since we're going to need to have native code for the locking system.
Okay, so the back end is the companion to the front end. It's what actually holds all the data of the system, and what bytes are checked out, who took what where, what maintenance requests filed, all that good stuff. The back end is written in Python 3, uses Django. This was a request of student government. They would like something that they can continue to use and modify even after program graduated. And Python 3 and Django are both accurate RIT, so there's a perfect choice from that standpoint. Another key part of our tech stack on the back end is a GIS-enabled SQL database. For example, SQLite or Postgres. And what this database allows us to do is allows us to do queries based on geometry. So for example, we can say, give me all the bytes that are within a radius of a certain point. Or we can say, hey, is this byte in a certain area here? And if it is, do something special. And it's much more efficient to do those types of things in the database instead of loading everything into Python and doing it there. So this really becomes a key performance enhancer of our system. One of the last things that the backend does is it provides triple-S support for us. Right now, the current vector by student government does not have triple-S support. In order to use the system, you need to create an account with its own username and password, And that's just something else for you to remember. It's not tied to your RIT identity anyway. You could spoof it, you could sign up with your friend name and have some lot of trouble. So we said, well, we'll add server support to ours. So you can log in using your RIT username and just go through.
The main centerpiece of our application is a map of the campus, which would eventually show the different locations of bike racks that have bikes available for you to check out. The second part of our main view here is the bottom button, which is very large, which is the main action of the application, which is to check out a bike. And on the far right here, you can see the view for when you have a bike checked out. You can very easily lock or return the bike, and you see a countdown of how much time you have remaining on the bike. And then we have a very simple fly-out menu for different settings and safety and that sort of thing. We gave these wireframes to student government and their designer to try and get better high-fidelity designs out of them. And we did. Unfortunately, we decided that the UX for these weren't up to par with what we thought the UX was for our wireframes. For example, the View Map button, the main action you're going to be doing when opening the application is you're going to be looking for a bike rack where you can go to get a bike. This View Map button made it one extra click for you to try to find where to get a bike, and then in order to check out a bike, you would have to back out the map and then go into Checkout Bike. This was not really a smooth work or a smooth flow for the user when trying to check out a bike. We wanted to make that as easy as possible. So that's why when prototyping, we went back to how our wireframes were originally and adopted the view that we designed there. So as you can see, we still have the main map as the view, the main part of the view here, and then we have still that bottom button, which is still very large with your main action to check out a bike. And as you can see, as we iterated on those different prototypes, we added bike markers and our tab 2, which ended up being our tab, or the tab for our settings. And then in terms of design on how we handle data on our mobile app, it's a pretty basic Redux workflow here. We had our views, which fired actions, which go to our reducers, which update our Redux state, and our requests, which we interface with Redux actions. And the only really thing we had in states were bike racks and the current rental.
Okay, so the back end is a pretty simple REST server. There's not a whole lot of special stuff that actually does. We use the Django REST framework to really eliminate a lot of the boilerplate stuff that other apps had to write. One nifty thing that the backend does use is GeoJSON to transfer spatial geometry to the front end. JavaScript has great support for GeoJSON, whereas the backend kind of uses a different format by default. So GeoJSON was just a really nice way to go between the front end and the back end. We were also able to take advantage of Django's built-in admin functionality, so we didn't need to write things for just populating the database with test data. So it was really a nice way to cut down development time in that regard as well. This is our domain model. You have your basic stuff here, pretty much everything you'd expect in terms of bikes, bike racks, users, whatnot. But one thing that we were able to do with this is bike racks and bikes are not tied together directly. Instead, they are tied together through a location object. This allows us to, in the future, if the student government ever wants to implement a drop anywhere system like Spin, the system will support it very easily. All we have to do is make bikes standalone and it's done.
Okay, so let's currently talk about the present state of our application. What have we got done this fall semester? So first, we've completed the mobile application foundation. We have everything check in, check out. Everything's working along with the Python API that was built out. The Python API is not fully complete yet. There will need to be some more additions for the admin web interface we need to build next semester. Here's a screenshot of our application right now. As you can see, you log in with your RIT and credentials, and on the right, the design is very heavily based on the Spin implementation, where the map is the centerpiece, and you're given a location of bike racks along with the number of bikes at each bike rack, so you can quickly find a bike near you. Next, we have the checkout process. So once you click the main indicator on the main screen, you're brought to a camera with a QR code scanner. You use the QR scanner to scan the code on the bike,
and assuming that the bike isn't damaged or doesn't have any report on it from the back end telling you you can't check it out, you're presented with a success screen that shows you some information about safety, anything that student government wants you to know during your bike ride. Check-in is similar. One of the core differences with check-in is that we leverage the GPS on your phone. So if you have GPS enabled and you've given us permission to use it, we can find the bike rack that's actually within a certain radius of you, and we can automate that process to check in there. Otherwise, if you don't have GPS abilities on your phone, you can use the QR code again to scan which bike rack you want to check into. This is currently a limitation because we don't, not necessarily a limitation, but until we have the ability to have an internet connected lock and student government wants to support drop anywhere, we think it's better to keep bikes on reasonable locations on campus. For the back end, what we currently have is all of the Django tools that are built in with using Django. So we get all of these for free, which is really great. It even includes an awesome ability to set locations on a map in the UI. We can use this to place test dummy bike racks and valid check-in areas. Now talking about the future. So what do we have planned for our app in the spring semester? First is to finish the mobile application. There are a few things involved in this. One is to integrate the actual bike locks, and the other is to actually add the official ship off into the application. We also need to develop the web application for administration to be used by people who need to do maintenance on the bikes and also other student government employees. We also need to update the Python API to support the admin web interface. Taking a little closer look into actually integrating the bike lock, what all do we need to do to support this? First thing that's really important is detaching from Expo. Expo is strictly JavaScript web technologies, so there's the ability to detach this, which will actually create two bundled applications for you, one for iOS and one for Android. Using this allows us to support our own native code. This is necessary because the bike locks they all require native code. The challenges here are that this obviously requires native application development, and our team in general has less experience in this field, and it also increases the complexity around our build and deploy process. The admin web application needs to provide administrative and any sort of maintenance functionality to people in student government. This includes adding and removing bikes and bike racks locations from the map, and also viewing and creating maintenance reports whenever a bike receives damage. Does anyone have any questions about the RIT bike share?
Good.
So when you're checking the bike rack in, you mentioned obviously you scan the QR code on the bike rack. Does that also use your location data? Because there's a scenario where if you're not using that, someone could scan a copy of the QR code, right? And pretend to check the bike rack in. Do you guys have a way to address that?
Yeah. So currently.
Sure. So that was addressed. We brought that to our sponsors and said that would be a concern. The main thing there is that assuming that we do get your location data, that is why it's the first step there. There's very little chance for people to spoof that. So that's why scanning the QR code is a fallback. They basically told us to assume that all RT students are good people and that scanning that QR code should be a source of truth.
Piggybacking off of that, there are not many third-party developers who will sell you a bike lock that includes GPS and internet built in. A lot of the companies that have these locks are trying to also sell you their bike share system, similar to Spin. So that's also a challenge there, is finding a lock that's not just Bluetooth enabled, but also internet and GPS.
I remember when you said you switched the interface from the SD file back to one you made, it was because you believe Spin was more user friendly. So do you have any plans days to actually perform usability tests on your interface or interface potential users, because that may not actually be the case, and a lot of times you get surprised at what user preferences are.
Yeah, absolutely.
So the idea there was that after we received those student government things back, we did have a little bit of period of time before Spin was released, but the idea is that since Spin was released and people have been so widely using it on campus, the idea to go to a completely different UI and have that kind of jarring transition for people that are going to be switching to the new bike share, the idea was that once that was released, we immediately switched to having a heavily inspired by Spin design so that transition would be not as rocky.
So your philosophy was we should make it close to what people are used to that.
Exactly. Let Spin do the user testing for us. Any other questions?
So given that this is an open source project, why do you guys come uninterested in doing documentation, despite this being something that could be important for the open source community?
How do you want to take this one?
I mean, we're performing code documentation. We're just probably not using as much of the Scrum documentation that you would expect, like sprints and metrics. But we do have code documentation, so everything that's open source will be documented.
Anything else?
All right, let's thank the team.
Yeah. Ladies and gentlemen, all right. Thank you all for being here. We are the Wegman, and our senior project is the Wegman Store Reporting System. Now, I'm sure that basically all of you have bought groceries from Wegmans at some point. Some things you might not know about them: they have over 47,000 employees across almost 100 stores.
And Fortune 100 has rated them the #2 best place to work for this year. They were #1 for a while. I think Facebook actually kicked them out of that this year. The other thing you might not know is that they have delicious prepared food. So depending on where you shop, that's going to be pizza or subs or sushi if you want. And each of those have a manager that Wegmans calls a chef. And based on the dynamic nature of those departments, they need up-to-date data for every day so they know what they have and what they need to purchase. So the way that they do that currently is with this. As you can see, it's about, you can probably guess, it's 12 years old. It has all the information they need. It's got the sales, some of the other expenditures and their contribution. And this is all fake data. Don't go try to sell it to Walmart or anything. So what does it do? There are two main features of the software currently, and that is to provide a summary of all of the sales and the expenditures for your department and your contribution to the store. And the second one is the ability to view all of the transfers into and out of your department so that you know what you have and what you need on a given day. There are some issues. Being really old, there are long load times. As you saw, the user experience is not fantastic, though it does get the job done. And the technologies are outdated. It uses an Informix database. I had actually never heard of that before we had this project. And it uses ASP Classic. So basically, Wegmans decided we want to add some new features to this software, but the technology is so outdated that it's not really worth it to do that. So instead, we're going to rewrite the entire system with new technologies. Now, that brings us to our requirement solicitation. So we actually have 5 Wegmans employees that come to our meetings every Thursday and help us out, and they're very wide disciplines. So Tony is our project lead. Brett and Matt are actually on the team that we're going to be handing our software over to when we finish it. Mike is an architect for Wegmans, and he's actually the original author of Store Pro that I just showed you. And Denny is an end user. He's a chef, and he is kind of our communication to what the users want. So the first thing we did when we got this project, there wasn't a requirements list. So we talked to them and had them show us what the system currently does and what it is that they want us to create, basically, because we didn't really know any of the stuff that I just told you. So we talked to them, got some basic requirements, and then we decided that a good idea would be to see the software in action. So we took a trip down to the Pittsford Wegmans and met with Brad, who is a daily user of the software, and had him run us through how he how he uses it and some of his pain points. So we saw where he does his work, and really it brought a better picture of what we needed to do. So after that, we had our requirements pretty good, and we went to the Wegmans corporate office and spoke with some of their upper-level management. So we spoke to the CTO, some of the business development people, and presented our understanding of the requirements and made sure that it matched up with their understanding of the requirements. So we had some constructive back and forth, figured out what we wanted to do, and this is what we came up with. So these are the new features that will be added. It is a given that our new software will be able to perform everything that the old software does because we don't want to remove functionality. So just to name a few, the chefs really wanted more than 7 days of data. Today's Thursday. If I wanted to look at what happened 2 Thursdays ago, because that could be helpful to me, you can't do that right now. So we're going to go up to a month. We'd originally said a year, and that was something that the guys at corporate decided they didn't want to be that long. Compare the performance of stores. If I know that my store and another store are pretty similar in size and sales, I can put my store next to their store and compare our contributions and see if maybe there's something that I can do different to make my department run more smoothly. Just to pick one more here, enhanced data visualization. Right now, as you saw, it's just a table, and a lot of information can be a lot more easily read if it's in a chart form or a graph form. So we're going to be providing both the table and the charts so that if you're used to the table and that's what you want, you can have it, but the new features are there.
So some of these things were determined to be out of scope after we had the meeting with the CTO and the big meeting at the Wegmans corporate office. One of these was using the system as an audit tool. It was expressed to us that this is not what the software is used for. They don't want it to be used for this, so we had to remove any requests perhaps for features that would act like an auditing tool. Automatic detection of incorrect transfers. This is something that was deemed out of scope as well. Detecting errors in the data using machine learning, also not what the software was originally designed for, so this was moved to out of scope. And the ability for a user to customize the interface was something that we went back and forth with them and determined at the end that this was going to be out of scope simply because the software was designed to be used for maybe 15 minutes a day, not for somebody to sit there and move their panels around and switch to visualizations they're seeing every single day. So for our process, what we use is a feature-driven development methodology. This is going to enable us to give high visibility to Wegmans. They can see what features we're delivering at the end of each sprint, so that way they can have that feel good when they go home at the end of the meeting saying, all right, they got stuff done. It documents each feature as it's developed, so this way we don't have to go back later on and document things that we might not remember. So we see the features are defined as an action or result in an object. For example, selecting a store, or select a department for a store. And we also participate in end of sprint reflections. In other words, what went right, what went wrong, what can we do better next sprint, and what might be worth writing down to pass on to the team that we're passing this on to, as far as what headaches did we run into dealing with some of the things in the sprint. So Visual Studio Team Services. This is what we essentially use for our project management software. This was handed to us as part of the tech stack from Wegmans, so we just ran with it. It can do everything from requirements management. It's got access to a Git repository, scheduling, task elimination. It can automate our builds and our releases. So it's very similar to Trello and other tools that you guys may be familiar with. As you can see, it's got the project board where we can drag our actions into active, closed. We can track our builds and releases. We can view the code. Everything at the top there are all tools supported to us by this piece of software. Risk management. So the way that we handled this was we created an Excel spreadsheet. On this Excel spreadsheet, we list out any risks that we might encounter for the entire project, and each sprint we're adding risks to this document as well, as far as if we find out new things that might be a problem or new problems arise. What we're keeping track of on here is the impact. We're keeping track of the mitigation strategies. What's the likelihood of this risk occurring? So weekly risk mitigation strategies, we're discussing it as a team with the coach and with our project sponsors. There might be some things that we're not familiar with or don't have the best idea of how to handle, so it's good to have the Wegmans team who has a wide base of knowledge there as a resource. So some design decisions. These are a few of the wireframes that we started off with. If you remember, we removed the customization ability to out of scope. Well, at this point, we had one that was very static. It looks a lot like the old system. As you can see, you've got your numbers right out front there, your store locations. The second one over here looks a little nicer, but it allows for some customization. And we had a third one as well that allowed for high customization, which was deemed out of scope. So this design is closest to the one that we landed on. Instead of, on this one you can see the plus button down there. This was going to give users the ability to add their own panels as far as what data they want to see. That was nixed. We are going to be having 6 static panels on here where you can switch between a visualization of the data and between that the view that you saw in the old Store Pro with the lines, just rows of raw data essentially.
So now we're going to move on to technology that we're using to implement this. So we inherited a lot of our technology from Wegmans. They currently deploy their applications to Microsoft Azure, and they use Microsoft ASP.NET to code it. So they would like us to do the same. But they gave us free reign over the front end, and so they wanted us to choose a framework that we liked to build the front end, with the caveat that we had to present our findings to Wegmans Corporate and defend our tech choices. So we decided that we would compare Angular and React as our front-end JavaScript framework. So Doug and I, since we have no experience with front-end frameworks, went home and learned tutorials of both React and Angular, compiled our findings, and compared notes to, and we both came to the conclusion that React was easier for us to both learn, read, and maintain. So we presented our findings to Wegmans Corporate, and they approved and let us move on with React. And then so for our CSS framework, we originally wanted to use Zurb Foundation for applications, but upon receiving some feedback from the sponsor, they wanted us to use Bootstrap because the team inheriting the project after us is more familiar. So some of the standards and testing that we're using TDD to test the server-side and to develop the back end. We wanted to focus this on the back end because that's where we feel our time spent would reach the most benefits. We did not want to use TDD for the front end because our application is going to be one page and we want to minimize the number of clicks on the page. So the time spent setting up the TDD framework and the unit test framework for the front end, we feel like we could spend that time better someplace else. We're using the Microsoft Test Framework as our unit test. We originally wanted to use XUnit, but we moved back to the Microsoft Test Framework to maintain the Microsoft ecosystem. We're using automated builds on VSTS, or whenever we check in a branch, it builds. We're using ESLint to standardize our JavaScript syntax, so we get a warning if we're doing anything wrong. We opted to include feature numbers at the beginning of our commit messages. That means our Git repository is going to be clean and directly mapped to all our tasks in VSTS, which we give the Wegmans team taking over the project an easy way to see what we did and how that associated to our work. We verify our features weekly or bi-weekly with our sponsors, depending on our sprints. And we demoed the product to them, and they give us feedback on the acceptance criteria and if our features meet that or not. So I want to take a minute to talk about our high-level architecture. So with the help of Mike from Wegmans, who is an architect, and he has a lot of Azure experience, we developed this architecture. We greatly appreciate his help because we do not have experience with Azure. So our StorePro system will exist inside of its own resource group using Azure SQL to store the data. And our application that actually the users interact with will be under an app service, which hosts the service. And Application Insights will monitor the status of our system, reporting on anything that is going wrong. We're using Azure Active Directory to authenticate, and our Wegmans has all of their users already in Active Directory, so that's an easy thing for us to interact with to approve chefs to use the system. I wanted to talk about the authentication architecture because it was really difficult for us to implement. It is not natively supported by Microsoft to use React with Azure Active Directory to supply a JavaScript library to use with Angular version 1. So Austin and I had to write a wrapper that goes around this library to ensure that we can communicate with React and Active Directory. So now the user can hit our front end and then be redirected to the Azure Active Directory, and once they submit valid login, they will receive a token to communicate with the web API and be redirected back to our React application.
All right, let me talk a little bit about the project metrics here. So we sort of approached the project with a set 10 sprint sort of cycle time. And as the velocity changes, the scope changes, not the length of the project. So if you take our average of 15 story points per sprint and extend that across 10 sprints, you get a project scope of 150 total story points. We currently have 141, so it fits just within that amount. If our velocity changes or we have a backlog of issues to take care of, that scope may extend and we may have to drop some requirements. Later in the project, we're actually going to track our requirement change rate. Right now, about 2/3 of our requirements are non-volatile and high priority. So that's not something that we're super concerned about at the beginning. So some of the process metrics we are using. So we're using a sprint disruption index. So that's tracking the amount of times a requirement has been added, subtracted, or changed in the middle of a sprint. We actually had 3 stories in sprint 2 that we had an issue with. So we had to go back after the end of that sprint and reprioritize our features. Another one we're using is test coverage.
Tests drive our development, so our coverage should therefore be pretty high. So that should help us assess the quality of our tests we're writing. We're also going to track, or we're tracking increment containment effectiveness. So we're trying to keep the backlog of issues low. So far we haven't had any issues with keeping issues within the sprint, but that's something that we want to make sure doesn't get out of hand.
So after we went through our requirement solicitation, determined what was in and out of scope, determined what our tech stack was going to be, we were finally ready to start our sprints and start coding, which is obviously the best part. We quickly realized that none of us really had any experience setting up this large-scale application. We've all done co-ops before, but we've all joined existing teams. And we've also done school projects, but those have been small semester things where we quickly spin up something. So for us, it was kind of difficult to understand how to make sure that what we're doing isn't going to fail in a year or 2 years. So for our sprint 1, we really just wanted to focus on the initial development setup. We originally had 2 projects set up in our one Microsoft solution, but we realized that that wasn't going to work because we were having a CORS communication issue. So we refactored that in our first sprint and arrived on one project, which would make things just a lot more easily maintainable. And then obviously it was a big success for us to, on the front end, be able to call the database on the back end and then display a message right to the client. It sounds simple, but for us it was a real big win. Moving on to Sprint 2, what Nick kind of talked about was we were having a lot of issues with our Azure Active Directory authentication. That was another CORS issue. We didn't really understand how to correctly authenticate ourselves and get that token back. Luckily, we were able to figure it out with a lot of help from outside people, especially Professor Martinez had some people help us. Along with Sprint 2, we went on with the initial skeleton framework for our application, and we were able to select a store and department. Then we just finished up with Sprint 3, which is going to be displaying packaging, shrink, and labor, which is some of those things that Brandon were talking about in the beginning, which are those very important features for our application. So looking forward to our spring semester, we have 10 total sprints planned, or allocated, I should say. We have completed 3 sprints and 7 more projected for the spring. You might be thinking, why is there only 3 in the fall and 7 in the spring? It's because we took so long with our requirements solicitation and overall just getting involved in the Wegmans ecosystem, because again, we want to make sure that this handoff to them is seamless. So from more of the requirements that we're looking for the spring semester is overall just hitting all those the current system features that we really need to make sure are in them, as well as some administration features, as in adding new stores to the system, because as Wegmans grows, there are going to be more stores appearing in the system, as well as goal tracking. So when the chef can say, I want to make sure that I want to spend under $5,000 a week on combined prepared or stuff like that, they will be able to see that very easily. Then the final 2 things would be the data visualization, which everyone's been talking about before me, as well as any stretch goals that we have identified. Before we break for questions, we really want to thank Professor Bellino for overall overseeing all of the senior projects this term and as well as next. We want to thank our coach, Professor Martinez, for being a great asset to us every single week. And especially we want to thank Wegmans and our 5 project sponsors for being there every single week as well. They've been truly, all 3 of them, or all of this collective group, has been really helpful for us in understanding how to go about our project. So at this time, are there any questions for us?
So at what point was it like you find application in order to maintain the minimum viable? So you said there were 4 features, and you said the scope would continue to change, so they could get to the point where you only have stuff done now and run it out for a while.
So I would say we haven't mapped out each feature to a sprint yet, because that happens continuously. If I'm just estimating, I would say we would probably have to get like over a sprint behind of features before we would not make the minimum viable progress.
Yeah, and our sprint velocity too, we perceive perhaps increasing a little bit, because we've had these growing pains through the first couple sprints, so perhaps more story points will be afforded in future sprints. We'll see how that goes.
biggest challenge and how have you addressed it?
We've obviously had a lot of different challenges. I think the biggest one is really making sure that our product is able to go right to Wegmans once we're done with it. A lot of these other senior projects, they're almost one and dones. They just live on RIT system or anything like that. They're going to be continually using our system for the next 12 years possibly. So we want to make sure that our product is perfect for them.
So you mentioned that you consolidated multiple projects into one. Have you already done like deployment to see how that worked out? And if so, do you think that will be able to go to scale?
Yeah, so one of the things that, again, we took so long with getting set up is we already have our application on Elastic IP that Wegmans can see every single week. So if they go in Monday morning, want to see the progress that we have for the weekend, they can do that. So luckily, we haven't had any issues since we moved to the one project.
I know a few of the features that you mentioned on Azure can be pretty pricey. Has cost been any impact from other?
So luckily, Wegmans gives us a nice allocation of funds every month that replenishes, so we can mess around and figure out what is the best way. We also have Mike, who is basically an Azure solutions expert, that he can really price out what it is going to be. So we might say, hey, we're thinking about we might need a terabyte of data every single month, and Mike will be like, no, absolutely not. It's going to be 2 gigs max. So that's definitely helped us a lot.
He's a wizard.
To add on to that too, during our presentation to the CTO, cost was a huge factor. When we were choosing our tech stack, we had to show, hey, so we're looking at this database and this database. This is how much it costs for this much space. If we use this one, this is how much it costs on this one. And we did some of our choosing based on that.
It's tricky though, because nothing's free over there.
Right. And obviously, anytime you're working with, in a corporate environment or whatever, numbers are definitely, a key factor in the equation.
Have you ever felt that bureaucracy be a strain on your project?
Not especially, no. Because our project sponsors are over a wide range of different abilities. We have a PM, we have an end user, and we have people who are actually going to be using our application, as well as the person who actually made the past one. Luckily, they can make all of those tough decisions right then and there, so we don't have to wait on a CTO's final approval per se.
Let's continue.
Hi. This is our interim presentation, orthodonties. Where are they now?
What doesn't? It doesn't work. Yeah. It doesn't work. Yeah.
Wait, what?
You can't move to the next slide.
Oh.
So at least I could click.
There you go.
I got you.
Yeah, left and right.
There you
Yeah.
So as I mentioned, we are the orthodonties. This is Alex, Ryan, I'm Ian, and that's Eric. Our sponsor over at Ortho Clinical is Jim and Rob, and our coach is Al. So what are we talking about? We're going to tell you a little bit about our sponsors, Ortho Clinical Diagnostics, and what they do. We're going to delve into the project itself, what it is that they came to us to get done for them, and the domain knowledge we had to acquire along the way. We're going to talk a little bit about our methodology and how we set ourselves up for success in terms of getting this project done in time. After that, we're going to dive into the tech stack, tell you a little bit about the technical breakdown of the domain itself and the code base that we've been working in, and the progress that we've made thus far, the plans for the future, and the lessons that we've learned. So, about Ortho. So, Ortho Clinical Diagnostics is a leading provider in vitro diagnostics. Found out vitro means tube. So, basically, what they do is they analyze different fluid samples. So, this could be anything from blood to urine. And they service over 100 laboratories in over 120 different countries. And they communicate with the hospital's laboratory information system, otherwise known as LIS. Keep that in mind because it's going to come up later. And they send tests to these connected analyzers and receive completed results in return. So what is the project? So it's complicated, but basically these analyzers require new sorts of implementation for their interface and testing tools because the communication protocols that they currently have been updated and with the hope of giving a more universal standard to hospitals that are integrating with them. So what is an analyzer? So the analyzer is the machine itself that analyzes the fluid samples. And so our changes focus on the back end of the analyzer software, which you can see brought up on that screen, which is how the physician interfaces with the analyzer itself, and the communication protocol that it uses to send this information.
So about the communication protocols that this analyzer uses, this slide is going to involve a couple of acronyms, so keep them in mind for the rest of the slides here. But the main communication protocol that we're updating is HL7, Health Level 7 International. HL7 provides the syntactical standard for how messages are going to look going over from an analyzer to a lab information system, or LIS. HL7 standardizes the structure of those two machines talking to each other because LISs are often implemented differently for each hospital, so there needed to be some sort of standardized implementation of a way for these two things to talk to each other. LAW, or Laboratory Analytical Workflow, is a definition for how some of these messages, or for what should be in some of these messages specifically. These messages we'll refer to as labs shortly. So it takes the existing standards of HL7, puts them into even more specific formatting, and that's the new structure that we're trying to implement. These messages are sent over the MLLP, which is the lowest layer of protocol standards that we're dealing with. So this is our domain model. You can see up at the top we have a physician who sends a test request into an LIS. That LIS creates a lab message or an HL7 message or lab 28 that goes through the protocol into our analyzer, and lab tech is able to see that. Then goes the other way. The analyzer creates a lab 27 or 29 message. and that's how the magic happens. We're mainly dealing in these HL7 message segments in bold on the left here. Yeah. So the last team that worked on this project was a senior product team. Their name was Reactive Healthcare. They have this really cool logo. I actually like it a lot. But they started the first half of the law implementation, which was full duplex. Full duplex was, it still is, the new way that these two systems are going to be talking to each other. So instead of speaking over one port and things moving kind of slowly, there are two ports now, one for sending data and one for receiving data on the analyzer, and vice versa on the LIS. And it allows for faster communication overall, and yeah.
So what a lab is, it's basically the communication between the analyzer that we were talking about and the LIS, or the analyzer manager. And so the three that we are working on, labs 27, 28, and 29 that we've mentioned, 27 is a query for an analyzer work order step. And so that's basically just the next step in the test that's currently being run. And these tests are, as Ian mentioned, like a blood or a urine sample that are looking for things like glucose levels or something like that. And so the query is the analyzer saying, hey, I'm going to run a test, what needs to be run? And the analyzer manager responds. The broadcast, lab 28, is like a physician putting something in the analyzer manager, which will then be sent over to the analyzer because the test needs to be run, and it's sent to a specific analyzer. And so then the analyzer has that and is ready to run. The AWS status change is results. So like after a test is run, if a lab tech on the analyzer wants to look at previous results, they can do or request a status change, and that'll send the message to the analyzer manager, the LIS, and get some information back. So the methodology that we chose is Scrum, and normally it's chosen because of changing in requirements, but we chose it because there's a lot of changing in our understanding of the domain knowledge. The application that we were given and are working on is really big, and so there was a lot of stuff that we had to learn about it, and so we kept learning more and more and more, and we wanted to be able to adapt to our understanding so that way we can properly execute what needs to be done. And so we have daily stand-ups that we do over Slack. We're doing 2-week sprints. We started off in 1-week sprints, and I'll go into that a little bit more in our metrics slide next. But we moved to 2 weeks. We also have a remote sponsor meeting every Tuesday, as well as our normal sponsor meeting on Thursdays. And this lets us ask any questions that we have, rather than trying to do it over email on a slower basis. We want to be able to ask questions more frequently. And so we have that. And then every other Thursday, we have our sprint retrospective prior to our sponsor meeting, and then our sprint planning after our sponsor meeting. So that way we can talk to them in between. And then we also have working meetings set up for Tuesdays and Sundays, so that way we can do a lot more peer programming. So our metrics that we are keeping track of, we have our sprint velocity, we have our percent rollover on sprints, and then also our time spent on sprints. And so as I mentioned, we started off with 1-week sprints. That was our first 4 sprints. And so you can see they were a little bit lower and they had a lot more rollover. And so we kind of found that the problem was we just weren't allotting enough time, and we were spending too much time doing that sprint retrospective and sprint planning and stuff. And so we needed more time. And also our understanding that we were talking about of the domain knowledge was really low, and so it just took us a lot more time to do stuff. So moving to the 2-week sprints, we've been a lot more productive and moving forward a lot more. Our 8th sprint doesn't have an actual because that is what we're currently in. We are just finishing up, or we have 1 more week on our 8th sprint, and so it's a little bit lower than our velocity because that's what we had planned for the full semester. We only have 12 points left in the semester. So, as far as our tech stack, we inherited the majority of that from Ortho. Taiga is the only thing that we really chose, and that's how we're measuring or keeping track of our scrums and our sprints. It's all through Taiga. But C++ is the language that the application is that we were given. The QNX Momentics suite is also how they were doing their development and their testing. And so we wanted to try and keep that as similar as possible to them, so that way if we have any questions, we have an expert to refer to. And then SVN was a mandatory requirement to use instead of Git. As far as our development environment, we are doing most of our development on a virtual machine, as that is where the analyzer is actually hosted. And so we have the drives mapped to our local machine, so we can write any code and stuff like that and look at the files on our local machines rather than having to VM and do it all through terminal and stuff like that. But all the analyzer is all run on the virtual machine itself. And then we also have a host-only network adapter that allows us to communicate back and forth, and we use the LIT tool, which is a simulated LIS system, the Laboratory Information Management, information system. And so that's where the messages go back and forth between the analyzer and the LIS or analyzer manager.
So in our requirements gathering, we had a unique problem to me at least. I had never run into this issue of having too much information about a project where it was difficult to parse it. We received a lot of documentation from our sponsors and from the prior team, and all of it was really informative. All of it was, or most of it was really helpful, but we couldn't narrow down what exactly we needed to do or what the changes were from 2.5 to 2.5.1 originally. So in order to remedy that, we had a lot of meetings and interviews with their sponsor. We had an on-site visit to really get an idea of what an analyzer was, how the users of the software go through it, what buttons they're clicking and stuff. And we went over the documentation of the prior group that they provided us, just how to set up dev environment, how to get tests running through, that sort of stuff. And a huge part of this project was setting up a gap assessment of the current code base with IHE's Gazelle tool. IHE is an organization that provides standards for this communication. And Gazelle is a web application that checks HL7 messages and tells you what's wrong with them, detects what they are, and tries to give you a hint as to what you need to change to get it up to standard. So some of the design decisions that we made were mainly focused on backwards compatibility. There's a large code base already there, and we can't go in and change the whole thing. We just wanted to make sure that anything that we changed wasn't going to break the rest of the system, while being able to implement new features and get this new protocol up to date. So currently you can see here that there's a configuration panel, and you should be able to switch between HL7 2.5.0, which is the current selected tab, HL7 there, and HL7 2.5.1, which is codenamed HL7FD there. So there should be a compatibility of both of those protocols on the fly. In order to achieve that, we wanted to be able to build messages for both protocols with similar structures to what's already in the code base. So we took the messages that are being built and added law build. So law, we mentioned, is the protocol that we're updating to. And in addition to the existing build message functions, we added law build message functions that just take the original build message and modify them with whatever needs to be done to get to the new version.
Alright, so when working to make sure these messages are up to standards, there's a lot of validation that takes place. IHE, as mentioned before, has developed the Gazelle tool, which allows us to check if these messages are HL7 and law compliant. We currently are doing manual testing. This process is basically just we take a message from our analyzer, send it to the LIT tool, take that output, and paste it into Gazelle. And that really allows us to see what errors there are within the message that's being sent, whether those be maybe like we're missing a segment or there's an invalid data type within a field. Gazelle also has a validation API, and we plan on using this in the second semester just to automate this whole process. For unit testing, we really had two options. We had Google Testing Framework and Lua Unit. We ended up going with the Google Testing Framework just because we found that it suited our needs better at the time. We do have plans for Lua Unit in the second semester as well, but that's mostly just to do system tests. So what did we accomplish this semester? A big part of this project was, this semester was just really learning the domain. We're working with a very large code base, and there's a lot of information that we needed to learn in order to fully understand the workflow of the system. We completed the Lab 29 gap assessment. As Alex mentioned before, this is really just focused on finding out what exactly about these specific messages we do need to change. We implemented our testing framework and started working on unit tests. And finally, we implemented Lab 29. So currently, right now, we are sending a valid HL7 and law compliant message. These were about 8 segments changed and total of 15 changes. So for our next semester, we have labs 27 and 28 to complete. And within those, we have to do a gap assessment, we have to do RIT tests, and then implement these labs. Although this may sound like a lot of work, we're not really worried about it because a lot of this semester was just spent really understanding the domain and understanding what the system does and how it works. We also have to do integration testing, and that would be just connecting with an actual LIS and sending over a valid HL7 message. As a stretch goal, we have FHIR implementation. FHIR stands for Fast Healthcare Interoperability Resource, and this is just a protocol. And instead of sending basically pipe delineated messages, we'd be sending an XML formatted one. So lessons learned. This is a very intricate and detailed code base, and so the ramp up time and learning curve was a little bit longer than we expected. Basically, there was a lot of documents that were given to us. There was Ortho's documents, there was IHE, and there was the previous team's documents. And so we really had to sift through all this information, and they were very acronym heavy. So just took us a lot of time just to figure out what these technical documents were talking about and what we needed specifically. The dev environment also took us a little bit more time to set up too, as well. There's a lot of communication that goes on between these applications, and they're a little bit finicky, so that was just a little bit tough. That leads us to time management. In the beginning of the semester, we had 1-week sprints, and we ended up trying to do like implementation along with looking up documentation and trying to do some process and setup stuff. So in order to mitigate that, we ended up switching over to the 2-week sprints. And also, in order to help us with that, we started doing pair programming, and this just allowed us to bounce ideas off each other and ask questions such as what does MLT mean, or where do we find this within this code base?
So that was our presentation. We told you about our project, about how we're updating the communication standards for these analyzers. We delved into the domain, the knowledge that we had to acquire over on-site visits and various interviews. We gave you a technical breakdown of the labs themselves and even the code that is going to be using it, and our methodology and our choice for Scrum and how it evolved over the semester. And we told you about our progress with Lab 29 and the testing framework getting set up and what we have left to do for 27 and 28 and full implementation. Any questions?
So why do you have a remote sponsoring and then an in-person sponsoring?
So that's because we kept coming up with a lot of questions. For every single one of our meetings, we'd have 5 or 6 more questions to ask. And so rather than trying to do that over email and work back and forth, which was a lot slower, we scheduled a remote sponsor meeting so that way we could ask those questions. And we specifically did that before one of our working meetings, which we also had on Tuesdays. So that way, any of those answers, we immediately had a meeting afterwards to then work on those answers that we were given from those questions.
Do you have to take any special considerations for security or compliance?
So most of that was already figured out for us. The requirements were very rigid in all the documentation we received, so we really didn't have to worry too much about implementing that on our own.
Also, the data that we're working with is completely mocked. They have a tool in there to generate fake data that makes development pretty easy for us. On the back.
Walk me through an example of how a healthcare professional uses this system, or how it's used internally, and some sort of.
Okay, so I guess if you were to go to the doctor, you'd let's say you had to take a blood sample, right? So your physician would order a blood sample through their system. You'd go down to the lab, and they'd call up that system, and they'd check their database and see whether or not that test actually exists. They'd grab that, you'd get your blood sample taken, and then they'd send that over to be sent to the analyzer to actually then run the test on the sample that you just gave them.
So we're making notes as we go along the way. We're planning on making a more formalized document set because the last team provided a really good one for setting everything up there. We're probably going to model it after their documentation and just add in some of the gotchas that we've encountered along the way. But yeah, we definitely thought about it.
All right, everyone. We are Team PTP Team Plus. My name is Kevin. This is Dan, Brian, and Josh. Our faculty coach is Dr. Hawker, and our sponsor is Paul Myers with Spectracom Corporation. So, who here owns a clock? How about 2 clocks? All right, put your hands down. You're ridiculous. Your 2 clocks, they're never quite in sync, right? I mean, they're close enough, like maybe they're the same minute if you're lucky, or a couple minutes off. And this is fine, right? It doesn't bother you. And maybe it bothers you. It doesn't bother me. So computers have this same sort of concept, but depending on what you're doing in sort of like distributed real-time applications, that really matters, right? So maybe you care, maybe you're trying to pulse distributed systems pulsing for sonar. You care that your systems are in sync to the millisecond, microsecond, nanosecond maybe. So to do this, IEEE has this standard, IEEE 1588, it's called Precision Time Protocol, and essentially this allows you, with special hardware support, to synchronize computers' clocks to a master machine and keep them within sub-microsecond accuracy, depending on the quality of your hardware. The way it does this is essentially you are you send packets out over the Ethernet network between two network cards, two NICs. And the hardware has support to timestamp it as sort of the lowest possible layer, the last second. And Precision Time Protocol implements the feedback control loop to estimate the network latency. And so you adjust for the latency of the network when synchronizing your time between your devices. So our project is to take an existing implementation of PTP, there's open source tools that do this, and a combination, purchase a Ethernet card that supports PTP, throw all this stuff together, get it all working, and see if we can get that to function within 300 nanoseconds. Additionally, I forgot to mention, you also want to synchronize typically to a GPS card, which gives you a source of real time rather than just having a local synchronization. It can be synchronized to UTC global time.
So how did we want to go about doing this? We decided to use a spiral development model, and we thought this was a good idea because there was a lot of risk with this project because none of us had no idea what the domain is, and spiral, one of the main focuses is addressing risks. So we determined the high-level objectives for our project, and then we used that to determine what risks were most prevalent. And then we use this to divide up the functionality into incremental deliverables, and then each one would help reduce the risk of the project so that we would have the best chance of being successful. So our schedule looked like this. First phase was research and architecture document, then a few prototypes to get things up and running and see what was involved with all of this PTP stuff. Selecting our final hardware that we would use for our final system, and then making our final system. So for a research and architecture document, this was a lot of the software engineering department deliverables, including the domain model, which helped us get the same picture of the system as our sponsor, the risk analysis, which came from our spiral model, and then our project plan, which included the requirements document, which we had our sponsor approve so that we made sure that we were doing what our sponsor wanted. So the first prototype, the main goal of this was to reduce risk by getting something up and running. We didn't need it to be very accurate, so we just wanted to get a couple of devices that the SE department had lying around. We were going to use software timestamping, which isn't the specialized hardware timestamping that Kevin mentioned earlier. It's a less accurate way of doing it, but we didn't care about that. We just wanted to get familiar with PTP and how it works. And once we got this working, we were going to do an analysis of the accuracy to see, just find out what's possible with software timestamping. So for the second prototype, our goal was to integrate get hardware support factored in. So the first part of that was one of the T-Sync GPS cards, which is a product that Spectracom makes, and they wanted us to use that for the absolute time source. Get the NICs integrated, and that would require doing research of what network interface cards are available on the market, picking the best one for our solution and actually purchasing it. And then once we got all that stuff integrated, we would run some more tests, this time with the hardware timestamping, and see what sort of results we could get for that. The testing for this was different than the testing for the software portion because each hardware component is able to output a PPS signal, a pulse per second. We would feed those into an oscilloscope, and then we would compare how accurate they are to each other. And we wanted to run another analysis there to see what does the results look like. So for the product and process, our first product metric was synchronization accuracy. And that fits in really well with our project because that is the main goal of our project, to get within 300 nanosecond synchronization. Second metric was risk exposure, and that fit in with our spiral model really well because each week we would address risks, put them into a risk chart, like we have an example risk there,
measuring the impact and probability to give us the exposure. And then we also include indications and mitigation methods, of course.
So for our hardware selection, we got 2 of the compact machines. You guys all know it. It's what we see all over the SE department. And then we ordered 2 Intel 210 Ti NIC cards, network cards. These cards were inexpensive for what they provided, which is the gigabit throughput, and as well as hardware timestamping capabilities, which were what we needed. And also, they play well with Linux, as we'll see later on. Lastly, we got 1 Spectracom T-Sync card, which is what we use to sync with a GPS antenna. So for our software selection, there were 2 main implementations. Actually, there's only 2. PTPD and Linux PTP. Linux PTP is a fork of PTPD that had hardware timestamping, and then it was later also implemented in PTPD. So we tested both of those, and we went with Linux PTP because we found that was easier to work with. And then we have a modified IGB driver. This was important for testing because out of the box, the Linux drivers for the NICs, for the Intel network cards, did not support PPS output. So we had to modify the driver so that we could get the PPS output. And then lastly, the TS2PHC is what allows the the system time of the computer to be set. Here is our deployment diagram. This is how everything interacts together. We have the T-Sync card connected to the satellite. The T-Sync can output a PPS that we use to sync it with the NIC card using TS2PHC. And then the NIC cards are connected via Ethernet cables, and PTP4L, which is the Linux PTP, is what allows us to do the PTP hardware time stamp and sync in between the 2 systems. And then on the receiving end, PH2sys is what sets the system time from the NIC card. And then also down there, the oscilloscope, that's not part of the final deliverable. That's just something we use for testing. And as mentioned before, we have PPS from both of the NICs and from the T-Sync that we can compare to see what the offset between the timestamps are.
So our first iteration for testing was focused on software timestamping. This was done in prototype 1, and we realized that this software timestamping was going to be inherently inaccurate due to the software nature of it. What happens is the timestamping is done at the software level and then is passed down through each of the layers to the NIC hardware and then across Ethernet to be picked up by PTP on the other side. Because of the time between the software timestamping and the time it actually hits the NIC, that produces an inaccurate offset when it reaches the other side. During this testing phase, it was primarily focused on what we could gain knowledge on and how we could use it. So we tested in Ubuntu, Arch, PTPD, PTP4L, as well as other configurations within those systems. During the analysis, we produced graphs, as you can see on the bottom, of the offset versus the updates. And then we also produced a histogram of the offset. And we analyzed to see how or in what range we were seeing for software timestamping. During our analysis, we analyzed, as I said, each of those configurations, and we saw that between Ubuntu and Arch, there was difference, but it was only a slight or
little difference between the two, and similarly with PTPD and PTP4L. So although we did try each configuration, we saw very little difference in synchronization accuracy between them. We did produce a configuration with high synchronization accuracy between Arch, PTPD, and a configuration of P2P, but as I said, Arch and PTPD weren't necessarily, were slightly different, had little difference. Now for our second iteration of testing, we focused on hardware timestamping. As I mentioned, the difference between the software and hardware timestamping is that the hardware timestamping is done just before the PTP package or message is sent over the NIC card, so on the hardware level. The focus, or the difference here was that instead of utilizing the output messages of the software, we looked at the pulse per second output on the devices that we were testing on. In this pulse per second output, as you can see in the right photo, we were analyzing the difference in the rising edge of the pulse per second on each of the devices. And the difference would be our synchronization accuracy. We tested 3 scenarios to determine the synchronization accuracy in the system. The first scenario is between the GPS card and the NIC on the master system. The next is between the NIC on the master system and the NIC on the slave system, and the third is between the GPS card and the slave NIC, or the NIC on the slave system. The results for our analysis were, for the software testing, we saw that most of the accuracy was around 40 microseconds. This was, we determined this okay because it was software timestamping. Another result from this area was that, as I mentioned, there was little difference between the OS and the PTP package that we used. For hardware timestamping, our synchronization between our master and NIC devices were around 10 nanoseconds. We saw this, as I said, from the pulse per second output difference on the oscilloscopes. The difference between GPS time and the slave NICs was around 40 nanoseconds. And by analyzing this, we can see that a base or informal testing procedure that we meet or go beyond our requirement of less than 300 nanoseconds. And then finally, our next step in our testing process is to perform testing over a longer period of time, so over around a day, as performed in our software testing, to see how our synchronization accuracy stabilizes over time. And then we also need to test on performance criteria over a switch to see how other traffic affects our performance. So some of the challenge that we had initially was familiarizing ourselves with the domain. The standard itself is a 300-page document. It's very thick, 3 C's there. But what we learned is that we didn't need to know so much about how PTP worked, rather how we can integrate it with a system. So instead of worrying about, oh, you know, this is exactly how it's done, it's because it was already been written, implemented. We just had to understand how that code would interact with hardware that we were trying to run it on. Next was that we had hardware involved, so we lost some time between ending our first prototype and getting the hardware required for our second prototype. So if we had requested our hardware earlier in time, we could have mitigated losing time. Next was getting drivers to work with the hardware. This was the most challenging part of our project, just because stuff did not work out of the box. So there was some fiddling, and one of the primary reasons we dropped Arch was that getting the Linux, getting the Arch to work with our NIC cards was becoming too much of a hassle, and we had to mitigate that risk by just dropping Arch. Future work. Josh talked about this a little bit, but obviously we still need to finalize our formal testing for the hardware solution. Our plan is to hook up the oscilloscope and record data over time to see if the results we're getting do not fluctuate and are constant. Next, we need to have a test with a network loop, see how that affects the system, and see whether we can get multiple slaves to work with the Grandmaster. And then lastly, we want to expand the project scope so that we have more to work with for the next semester.
Any questions?
So, when you're going over your spiral, it looks like you only have one spiral for next semester. Is that the case?
That is the case. Originally, due to the fact that we didn't really understand what we were getting ourselves into initially, next semester, the intention was we would get as much of the hardware as possible off the bat, and then we expected to be behind in our synchronization. We expected to not have 300 nanoseconds, and so at that point, right around now, we would sit down and say, okay, what are we going to target to optimize first? And so that spiral would be broken up into more spirals in the semester based on what we came up with. As it turns out, we've already met the requirement.
Why did you meet the requirement?
So pending some more formal analysis, the requirement was to keep the T-Sync GPS cards synchronized to the slave machine, keep everything sort of synchronized within 300 nanoseconds, and after observing manually on the oscilloscope for around 10 minutes, we saw that the synchronization was within 40 nanoseconds.
So why did your test setup allow that to happen? The question is, in response to the question is, do you understand why can you explain to the audience what your idealized test setup was, and then how you think you're going to add additional network traffic to make it a more real-world scenario?
Okay, so to go back over how the testing works exactly, each network card has its own clock, which it's using to timestamp the packets. The pulse per second, right, is a square wave over time, once every second, and that pulse is on the second, synchronized with the clock of the network card. So it's a little zoomed out here to really see, but if I pulse right when I think the second is, and you pulse right when you think the second is, and we compare what the offset is, that gives us a measure of the accuracy. And so it moves back and forth as these different components are working. Now there's 5 clocks in the system as described. There's 5 main clocks. Yeah, there's 5 clocks. So there's the clock on the T-Sync card. There's the clock with of the system time of the Grandmaster, the clock on the network card of the Grandmaster, the clock for the system time of the slave, and the clock for the network card of the slave. So the test that I was just mentioning that image is from is connecting the T-Sync card to, comparing the T-Sync card to the network card of the slave, and that's where we're getting our 40 nanoseconds. Now, beyond that, there's additionally the synchronizing from the network card clock to the system time clock, and there is some latency involved there. PHC2sys, this tool that synchronizes the two of them, outputs some metrics as well, and they are within tens of nanoseconds of the readings. Same as with this TS2PHC tool, which synchronizes the network card of the Grandmaster to the system time of the Grandmaster. And so combined, depending on what you're measuring the offset from and to, your synchronization will be a little bit different. Yes, so everything should still be within that 300 nanosecond based on what we observed, but that is pending a formal test. All of this is informing the results. The network is a direct crossover cable from the network card on the Grandmaster to the network card of the slave. And so part of our testing in the next couple weeks will be hooking up a Ethernet switch, which I believe we discussed Spectracom would provide, which has hardware timestamping capabilities, and seeing how that impacts the synchronization. However, it's not an explicit requirement. With regards to the 300 nanosecond requirement, that is without the switch in the loop. The switch is intended to see how the synchronization is impacted by other devices. In the back?
So, if I'm seeing this correctly, maybe I missed something. It's all been hardware stuff, essentially, right? So you guys did not design any software or anything?
That's correct.
Okay.
What's the reason behind the 300 nanosecond requirement? What is the system being used for?
Yeah, the business value. So, in general, we are sort of a antagonistic development team. The intent is to demonstrate that we're able to combine existing components and provide sort of a competitive product experience, whatever you want to call it, to something that Spectracom already does. And so the intent is there to show that there is a business risk, or that some action may need to be taken if a team of if a senior project team can produce results using free components that are similar to a product that they provide.
So there's no expectation that these would be located at different geographic locations?
No, there's not. This is for a local area network.
The network is larger than this, though. The network would consist of a switch or switches, network switches, and there's going to be a considerable amount of additional traffic. So in the coming spring, the scope expansion should include injecting other forms of traffic, which should make your idealized estimate meet the requirement question.
Thank you.
Okay. That's 9:15.